All right, we're back. We are on page 287, and we're going to start talking about one of the fundamental questions in calculus. And that question is, and it sounds like incredibly simple when you hear it, and it kind of isn't really that complicated a question. It's a great thing to wonder about, but it's basically this. What is the slope of a curve at a point, at one point? Algebra has already dealt with the idea of the slope between 2 points. Calculus showed up and was like, what if we only had 1 point? And like, draw yourself a curve and then imagine it as like a roller coaster, right? The roller coaster, there's definitely a slope at every point. Like you might initially think like maybe I'll just use like the angle of inclination as a slope, which is fine. But in other contexts, you would want like a more general idea. You don't want to have to be stuck with trig. So we are going to talk about how we can figure out the slope of a curve at a particular point, at one point. And the way we do it is we start with 2 points, and then we're going to let them get closer and closer to each other. So I'm going to be flipping back and forth between the calculator and the notes here. When I'm on the calculator, you should probably write in the notes. So let's see the setup here. So we have a curve. It's f of x is x squared minus 1. And then we're really interested about the point x equals 2, right? So if we're really interested in the point x equals 2, then what we want to do is fix that point, and then we'll take other points on the curve and write the equation of the line passing through them, find the slope of that line, and see what happens. So we're going to try to generalize this process. So let's see. All of them are going to, so we're finding slope. Every time we find slope, we're going to use the point 2 f of 2. F of 2 is 3, so I don't know why I'm like hiding that fact. But what we're finding, where can I put this? All right, I'm going to put it over in this corner. We are constantly going to be finding f of x2 minus f of 2 over whatever x2 is minus 2. So we're going to calculate that over and over again. And what we're going to do is we're going to change x2 as we go through it. So you can fill in, some of these you can fill in by hand. So like f of 5 is 24, or f of 5 is 24, f of 4 is 15, f of 3 is 8, 6.25 will be 4.25, 6.25 minus 2.5. How did I do that? 6.6 what am I even doing? 6.25 minus 1. I just have to subtract 1. 6.25 minus, I apologize, I've confused myself. Let's square 2.5. We get 6.25. Let's subtract 1, 5.25. You know what, maybe it's time for the calculator. So let's do that. Let's switch over to the calculator. We can probably set this up and do it very efficiently. So to switch to the calculator, got to switch over, share a calculator with you. Okay, so I'm going to define f of x is x squared minus 1. Let me check what I got so far. F of 5, f of 4, f of 3, f of 2.5. Do you get the sense that the numbers are getting closer and closer to 2? Because that's what we want. So we're doing very numeric right now. We're going to look at it graphically in a minute or so. So now I need f of 2.25. Oh God, what? I've never done that before. Did you see that? 2.5. Somehow it interprets as multiplication. That's crazy. All right, let's do it right. 2.25. So let's copy that. 4.0625. 4.0625. I put that in my table, in my notes. 2.125. 3.516, I guess. Let's go 4 decimals. 3.5156. So no, I don't really know how many we need for this to like look good. 2.063. We're getting closer and closer and closer to being at 2. That's like our ultimate goal is to just get there. So 3.256. No, we were going how many decimals? I'm gonna go 3.256 on this. You should be consistent, but like it's gonna round and round and round, and it's gonna be terrible. Well, actually, you get that no matter what. So yeah, let's use that. F of 2.005. This is taking forever to just plug in numbers. 3.020 and like 0. Okay, so those are my values. Now the next column in the notes, what we're filling in is m. We're filling in the slope. So I'm going to define a function called m of x, the slope at x. Why can I do that? I can do that because it's just going to be f of x minus. That second point is always at x equals 2, so f of 2 over x minus 2. Look at that. It's a difference quotient. That's a big deal. Difference quotients are a big deal. So now what I can do is I can just say, find me m of 5. And I'll get a decimal just in case. So I get 7. Okay, filled that in the table. M of 4, 6. Okay. M of 3 is 5. All right, where are we going with this? I don't know. M of 2.5, 4.5. M of 2.25 is 4.25. Okay, hold on. Are you noticing a pattern here? Let me go back to my notes. You may be noticing a pattern. I don't know if you're noticing a pattern or not. Look at the values that we're getting for the slopes and the x values that we're plugging in. Like, what is happening here? Like the difference between 4.25 and 2.25 is 2. The difference between 4.5 and 2.5 is 2. The difference between the slope and x2 seems to always be 2, which is kind of weird. And I don't even know if that's the pattern that we want to find, but you always want to look for. So the next one, I think, should be 4.125 and then 4.063. Those are my guesses. I'm going to actually fill them in. So I'm going to say, I think this will be 4.125. I think this will be 4.063. I think this will be 4.005. Let's see if the calculator bears that out. So you always want to look for patterns. Sometimes you find patterns, they're not like wrong. They're just like not useful. 4.125. M of 2.063. 4.063. What? M of 2.005. 4.005. Crazy. Okay. So if you at this point had to guess what the slope was going to be when we got to exactly 2, let's see what happens when I do m of 2. Do you know what's going to happen? It's going to be f of 2 minus f of 2 over 2 minus 2. 0 over 0. So it should just be undefined. And it is. What about m of 2 point, lots of zeros and a 1? It rounds it to 4. What about, so I should also come from the other side, right? I'm trying to, basically now I'm just finding the limit as x approaches 2 of f of x minus f of 2 over x minus 2. So if I do 1.99999, that's probably the same. I also get 4. I'm going to definitely guess that the slope here is 4. So let me go back to the notes and see if that makes sense. So back to the notes. Here we go. All right. So, I mean, based on the table, if I had to estimate the slope, I would say the slope at x equals 2 seems like, whoa, it should be 4. I mean, if the trend continues, why would it not be 4? That's the worst 4. It's got like extra parts. Seems like it should be 4. Now, I do want to add one thing to this column, this unknown column. Let you in on a little secret. I like couldn't remember what to do with this column for maybe like 5 years. Like I wrote the notes, I used them for a year or two, and then all of a sudden when I got to this one year, I was like, I don't know why there's this blank column. The reason there's a blank column, we're going to call it H. So we're going to say this is H. And actually, let me put it over farther. We're going to say this is H. And what H is going to be is it's going to be the difference between x2 and 2. It's how far are you from x equals 2. So when you're at 5, you're 3 units from x equals 2. So this is going to be x2 minus 2. Another way of thinking of that is delta x. It's your change in x, right? If we start at 2 and we use 5, then it's 3. Then it was 2. Then it was 1. Then it was, what am I doing? 0.5, 0.25, 0.125, 0.063, 0.005. Do you see another pattern? I think I do. So start at the bottom of the table and look at the rightmost two columns. It looks like actually the slopes, another way of thinking of them, they appear to always just be 4 plus h. It looks like we're always getting 4 plus h, right? If h was 15, I think I would get 19 as the slope. So what did I just say there? If h was 15, I think I would get 19. And if h is 15, then this would be 20. So I feel like it's not even worth it. I think it would definitely work. But so I have this column, and you can see that in this process, h is definitely approaching 0. So let me just show you. I'm going to switch to Geogebra, and then I'll probably switch to another video because this is probably getting long. But here's Geogebra, and I've set it up. So I have the function f of x is x squared minus 1. And I have the point 2 f of 2. So it's right here. And then what we're doing is we're finding, so like 5 comma f of 5 is this. And you can't even see it. Let me move this. Now you can see them both, right? What I'm going to do is I'm going to put a line through those. So you can do that in kind of a weird way. I'm just going to say line of AB. So I put the line through that. But I want a different, what's a way to do this? Settings. I don't know. I want this to change it for like everything. Style, scripting, advanced, basic. Where? Can you not do this? What I want to do is I want to make it so that it's always showing the line in slope intercept form. Oh, here we go. Y equals mx plus b. Okay, so I get this. And then I'm supposed to do 4 comma f of 4. Okay, and then I put a line through that. So it's the line through A and C. Awesome that I'm gonna have to change this every time. Slope intercept form. So the slope went from 7 to 6, and then I would do 3 comma f of 3. And you can see, sort of, maybe, potentially, line from A to D, that the slopes are getting less extreme. And I think that what they're doing is I think they're tending toward 4. I think the slope overall is going to tend toward 4. So let me do, let's do 2.005 comma f of 2.005. That's a very small difference, right? Like 2 and 2.005 are really, they're 0.005 away. So if I do the line there, A to E, and then if I change it, what the? A to E, there's no Y. It's like a weird, almost vertical line. What is that? Do this. What was that? I have no idea. That was weird. Look at that slope, basically 4. The closer that I get to 2, the closer the slope gets to 4. So then you just make that logical leap. Like, if I could get to 2, it feels like the limit of the slope would be 4, and that's exactly what we're finding. So I'm going to go back to the notes because for whatever reason, I really like to end the notes on the notes, or end the videos on the notes at least. So we're back. And what we're going to do next is we're just going to continue. We're going to develop this idea. Seems like we can use some sort of limiting process to find the slope at a specific point. And that's a big idea. And that's where we're headed. So I'll see you in the next video, and we are going to keep talking about this. So, show up. See you then.